Hey kiddos! Today we are going to be talking about triangle congruency, and we're going to be focusing on two types. So last time we also talked about hypotenuse leg. So today we're going to talk about two different ones, which are SSS, which represents side, 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 and SAS, which represents side, angle, side. So side, side, side. If three sides of one triangle are congruent to three sides of another triangle, then those two triangles are congruent. So as you can see here, it's very important to make note of our different markings here. So we can see that line AB, line segment AB, is congruent to the second triangle to line segment XY. And I know this because they're marked the exact same way. It's kind of the dead giveaway. So CB, line segment CB, I know is congruent to line segment ZY. And AC is congruent to XZ. So because all three sides are in fact congruent to each other, then we can write our triangle congruency statement as triangle ABC is congruent to triangle XYZ. All right, so let's look at this first example. Now, anytime they give you information, you always want to make sure that on the actual picture that you make marks. You mark what they're telling you. So here they say that JN is congruent to MN. And they also tell me that JK is congruent to MK. So notice I marked these to be congruent. Now, we're trying to prove that these are in fact congruent. Is there another line that both of these triangles have in common? Well, let's see. Sometimes it helps if you separate triangles, although some of you may already see it. Some of you probably have noticed that this line right here is shared between both triangles, which means this is actually the reflexive property, which then tells us that therefore NK would have to be congruent to itself, NK, in both triangles. So as you can see, we have three sides that are congruent. So triangle JNK is congruent to triangle MNK by the rule of side, side, side. Now, example 2 is asking, is triangle QPT, so this triangle here, is it congruent to triangle RST? Yes or no, and then what's our reasoning? Well, let's see here. We can see that they do have, we can see that QT, aren't y'all just cuties, is congruent to RT. We can see that QP is congruent to RS. And we can also see that PT is congruent to ST. So we can see that it has three sides that are congruent to each other. So therefore, yes, this triangle would be. Okay, notice if you flip this triangle over on top of triangle QPT, it would fit right on top of each other and everything would match up perfectly. So our reasoning is going to be side, side, side. Example 3. Is triangle SPQ congruent to triangle SRQ? Yes or no? Explain our reasonings. All right. Hopefully you do see that SQ in the middle belongs to both triangles. So therefore, I can make this marking here. So they do have those triangles in common. Now the question here is, think of if we flip this over on top of this, would it match up appropriately? And if you don't really see that, you can always help yourself out by redrawing the picture. So if I were to redraw RSQ, it would look like this. And R to S has the 2 markings, Q to R has the 1, and then SQ has the 3. Notice when I redraw it, it looks just like triangle SPQ. So because they are congruent, their sides do match up, then this would also be a yes because of side, side, side. All right, now let's talk about side angle side, SAS. If two sides and the including or included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So this time we're incorporating an angle. So we're not just looking at all the sides, we're looking at an angle as well. But the angle location is very important. Notice in the word or in the letters SAS, the angle is in between the two sides. So that's exactly how it has to look when we're looking at these triangles, okay? The angle has to be in between those two sides. That's what included angle means. So we can see that AC in this triangle would be congruent to XZ. We can see that angle A, having this one mark, this one curve mark here, is going to be congruent to angle X that also has the same. And the other side that we can see is congruent is AB, and AB proves to be congruent to XY. So because of that, we have a side, an angle that's included, and then another side, and we can justify that triangle ABC is in fact congruent to triangle XYZ. So just to reiterate an included angle, okay? The angle is formed by the two sides of the triangle. So examples, the included angle of line AI and AP is this angle here, and I'm going to mark it so that you guys see it, would be that angle, okay? Angle IAP. Remember, make sure we understand how to read these angles. IAP is in reference to this angle here, okay? The included angle of IP and PR would be angle IPR. So it would be this angle here, and I will mark it there. So that's in black. And the included angle of IA, so where is IA? IA. And RI is angle air. So that would actually be this whole angle here. Okay, so very important that you guys are able to identify what the included angle is or where it is. It's always in between the two specific sides. So basically where the two sides touch, it's that angle that is going to be considered included. So identify included angles. Name the included angle between the pair of sides given. All right, so let's do two of these together, and then you will do two of them on your own, okay? So you'll do those solo. So A, SP, SP, SP. Here we go. There's SP and PT. So if I'm looking at those two sides, the angle that is included is that one, which is angle SPT. And yes, I want you to name your angles by using 3 letters. All right, now let's look at the next one, which is side TR. TR is here, and QT is here, and the angle that would be included for that would be this angle here. Notice I'm looking where my two lines meet. They meet here, so this is the angle that they're in reference to, which is angle RTQ. Or remember, I could have also named it QDR. Okay, so keep that in mind. Go ahead and try C and D. Good luck. All right, now let's use our side angle side and properties of shapes to help us figure out this problem. In the diagram, QS and RP pass through the center M of a circle. Now, hopefully you guys know something about circles. Hopefully you guys recall diameters and a radius, okay? Diameter is the length from one end of a circle to the other end going through the center. Radius is half of a diameter. So if we have two lines, QS and RP, and they go through the center of them. Basically, they are the diameters of this circle. Okay? So mark all congruent sides and angles. Now, we would know then that this angle would be congruent to this angle, and this would have to be congruent to this, because those are the radius. Technically, they're all the actual same value, so I could actually technically make them all have the same marking because they're all the exact same value. And then, do we have another angle that's technically the same? Hopefully you guys are recalling an angle pair that we do know, which are ones that are located across from each other, which are our vertical angles. So we actually have a pair of vertical angles. So we've marked all our angles, our sides and angles that are congruent. So what can we conclude about triangle MRS, just this triangle here, and angle MPQ? Hopefully you see that what we conclude is that they are actually, the triangle MRS is congruent to triangle MPQ because of side, angle, side. They have SM being congruent to QM. We have RM being congruent to PM. And we have that included angle, angle SMR, being congruent to angle QMP. So because we have that included angle and those two sides, that proved it to be side, angle, side. All right, example 3, trying to prove why this triangle is congruent, if it is. So let's go ahead and mark what they tell us. They tell us that angle TVU, where is it? Angle TVU, this angle here, is congruent to triangle WUV, which is this angle here. So those two angles are congruent. And they're also telling us that VT is congruent to UW. All right. And that's all they give us. All right. Is there anything else we know? So we have a side, we have an angle. Do we have another side? Hopefully you guys do see that VU is going to be congruent to itself in both triangles because it's in both triangles. So it seems that we have proven that the triangle TUV is congruent to triangle WUV by side, angle, side. We have the two sides and the included angle, which is important. So you have a side, then the angle, then the side. All right, you're making a canvas sign to hang on a triangular portion of the barn wall shown in the picture. You think you can use two identical triangular sheets of canvas. You know that RP is perpendicular to QS, and notice you can see the marking here. If it's perpendicular, that means it's created in 90 degrees, so this is a right triangle. And PQ is congruent to PS. Can you use SAS congruency theorem to show that triangle PQR is congruent to triangle PSR? So we have one side and an included angle, The key here is to find that other side, a third side. Do you guys see a third side that both triangles in fact have in common? Hopefully you do. Hopefully you see that RP belongs to both triangles. Therefore, it would be existing on both triangles. So therefore, it's going to be the exact same. So it'll be congruent. So now the next thing to make sure is that the angle is an included angle, meaning it's in between those two sides. And hopefully you do see that where RP and QP meet, that 90 degrees is included. And on the other triangle where SP and RP meet, again, that angle is also included. So, can you use? Yes, we can. Okay, you most definitely can. Make sure that you do show these markings on your picture because that's what justifies us being able to prove that. All right. This is going to be a combination of side, 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 and side angle side. So state whether the two triangles are congruent, yes or no. And if they are, so if it's a yes, then I want you to also write whether it was side, side, side or side angle side. Make sure that you make any needed markings to prove things that are congruent. Okay. All right. Adios.